very good afternoon to all of you. Okay, so in this session, we are going to solve some BARC practice questions. Okay, so the questions will be of similar level to the BARC. Okay, so as we all know, the BARC exam and they conduct their own exam written test, right? So obviously the syllabus is almost similar to the GATE exam. So we can attempt that exam also if you have prepared for the GATE exam. Okay, so here we are going to see some sample questions and we will be solving that. Okay, of the subject engineering mechanics. Okay, so be ready, guys. We are going to solve some sample examples of BARC. Okay, so come on, guys, everyone. Okay. So as I can see, a lot of students are joining. Good afternoon to all of you. Okay, so we are going to start the questions, question solving. But before starting, I will show you all the questions that which we are going to solve. Okay, just we'll have an overview of that. Okay, so are you guys ready? Good afternoon. Good afternoon, Sumesh. Good afternoon. Good afternoon, everyone. Good afternoon, Jubair. So be ready, guys. We are going to solve some practice questions. So if you like the subject engineering mechanics, you will be enjoying this session, that I can be sure of. Okay, so come on, everyone. Okay, so let me show you the sample questions that we are going to solve. This is one of the question of friction topic. Okay, so that we will be seeing how we can solve this question. Then next question will be of this kind of thing. Okay, here impact and all this thing will be included. Okay, so this is the second part of that question where options and the diagrams are given. So this will be our second question of today's session. Okay, so I hope you are able to see the screen, right? And am I audible, right? Correctly? Yeah. So the next is this third question, and here they have given some scenario and the diagram is not given, so we have to visualize that thing what they are actually giving us. The next is again this where we have to find out the average impact force. So the question is from impulse part. Okay, this is the next question of equilibrium where they are asking us maximum allowable tension in 1000 Newton is, okay, 1000 Newton. Okay, so maximum allowable tension is given to us. We have to find maximum mass of the block, okay, that we can give it to. So this is the another question. Then this is the question of free body diagram. So we have to find out which one of the option is a free body diagram of this particular question. Okay, scenario. So are you guys ready for the solution? Okay, so here the next one is this, the balloon is going up. Okay, so this is also the another question. Then this one is also the another question of equilibrium where one block is hanged on the wires and we have to find out the tension in BC wire. Okay, so that we can do, and here we'll be ending the session. Okay, so these are all the questions that we are going to see in the session. So guys, be ready, and I'm going to share the screen of OneNote. Okay, so come on, guys. Okay, so let me show you the screen. Okay, so this will be our first question. You guys can try and solve it and get me the answer. Any one of you. Okay, let's try this and let me know the answer, what you are getting. Okay, come on, everyone. Yes, obviously, live के बाद भी available होगा, but in live you can ask your doubt at a time, and I can clarify there only. And also that is the benefit of live. So that's why that will be the benefit you can take. You can ask your doubt at this time only. And so that is the thing that you can get in the live session. So this was the question. Let us see what we can do here. Okay, let us see what we can do here. So a block weighing 200 Newton resting on a surface, okay, resting on a surface is given, and its static and kinetic coefficient of friction between the block and the surface is given. A horizontal force of 110 Newton is applied on the block. What is the magnitude of the force of friction acting on the block? So we have to find out the magnitude of the force of friction. First of all, we will check out what is the limiting friction force. What is the maximum limiting friction force? Okay. So what is the limiting friction force? Limiting friction force means this one. Okay, Fs. What is this limiting friction force? Limiting friction force is mu s into m into g, whatever the mass and the mass of the block is there. So that is 200. So static, that is 0.5 into 200. How much it is, guys? How much it is? So that will be 100, right? That will be 100. Now 100 Newton is the limiting friction. Means to move the block, I need the force which should be greater than 100 Newton. And obviously, if you see, the applied force is 110, means which is greater than 100. So obviously, block will not be in the impending motion. Block will start the motion. And now, so if block is starting the motion, then if we will make the free body diagram of it, so block will start the motion, means this is 110 Newton, and this is the friction force of 100 Newton. Okay. Now we have to see what will be the friction force at this time. So obviously we are going to find out the kinetic friction at that condition, because box is in the motion, the block is in the motion. So the kinetic friction of force at that instant will be only the friction force here. Okay, so this Fk will be nothing but mu k into n. So that is nothing but 0.3 into 200, and 0.3 into 200 will be the friction force here at this time. That is Fk. Okay, that will be Fk. And how much it will be? That will be 60 Newton. So 60 Newton will be the current friction of force when block will be in the motion. Are you getting or not? Not the 100 one. So many of the students might do it incorrectly, yeah, because they may get this 100 Newton as the answer. But a correct answer is 60 Newton, because block was in the motion. So first of all, you have to check whether the body is moving or in stationary. So if applied force is less than 100, if applied force is suppose 80 Newton, then in that case, friction force will be nothing but 100 only. Oh, not 100, 80, because box is not moving at the time. So 80. So whatever the force you are applying, that will be equal to the friction of force, because box is not moving. Are you getting or not? So at that time, friction force will be 80 only. I hope you are getting my point. So C is the answer. Kumar, Vasu, B is not the answer. So the solution is clear to everyone. So now we are going to move ahead for the next question. Let us see the next question now. Okay. So this is the next question, guys. A bullet of mass m1, 100 gram, okay, 10 gram, fired horizontally with the velocity of this. So we have given v1, v1 is given to us, v2, v, okay, and this is nothing but mass of the bullet and the mass of the block, which is stationary, means its velocity v1 dash is 0. Okay. Now bullet remains embedded in the block, means bullet is inside the block, so the mass of the whole system is not changed. If the coefficient of friction between the surface in the context remains 0.3. So if coefficient of friction is 0.3, then distance the block move before coming to rest. So we have to find out how much distance the block will move. So first what we will do, there are two states. The first state is this, where the bullet is just about to hit this. Okay. The second state is something else. The second state is this, where the bullet has been embedded in the box. Okay, this. And at this situation, we want to find out the velocity. Once we are able to find out this velocity, now we have to find out how much distance the S it will cover when it will come in the rest. That is the final state. That is the final last state. That is the second state. And the first state is this. Okay. Now, at the second state, we have to find out the velocity. So we will use the conservation of momentum. Conservation of momentum. So m1 v1, m2 v1 dash is equal to m1 plus m2 into v. That is the conservation of momentum when the both objects are collapsed. Okay, they are plastic collision. So v is what? m1 v1, and this is 0. So m1 v1, m1 is how much? 100 gram. So 100 gram into v1, v1 is how much? 180 meter per second. And now m1 plus m2, so how much? m2 450 plus 10, that is 460. So this is going to be something. Okay, so what it will be? Come on, tell me. Let me know the answer of this. Okay, so this will be cancelled out, and let me know the answer. This 0 and this 0 will be, what will be p? On the chat box, come on everyone, let me know the answer. Come on, guys. Let me know the answer. What will be this? Okay, so 3.19 something. 3.913. That will be the velocity of the whole system at the time. Now, with this velocity, means right now there is some kinetic energy of the system, and with the help of this kinetic energy, finally the object is in the rest. So how much distance it has been covered? Okay, it has covered. Now there is a friction is also given. Okay, so what is happening now here? Whatever the energy is there for the whole system, that has been lost in the friction. So whatever the work done by the friction force, that is nothing but the friction force into the displacement, whatever the displacement it will do. So this work done will be equal to this energy which has been developed at the state 2. Okay, so here from here we can get S. Now m v square by 2 divided by f. F is nothing but mu mg. M and m can get cancelled, so we get v square by 2 mu mg. So v square is nothing but 3.913 whole square into 2 into mu is how much? 0.3 into g is how much? How much g we have to take? G we have to take 9.8. Okay, so in the question you have to keep in mind ki they will many times they will give g as a 10 and sometimes g as a 9.8. So you have to check in the question. Okay, so now let me know what is the answer finally coming. Which one is the correct option? Which one is the correct option? Come on, guys. Let me know on the chat box. So which one is the correct answer? Okay, so we have to square this. We have to square this, then divide by 0.3. Okay, then divide by 9.8. Then divide by 2. Okay, so how much is the answer? How much is the answer? 2.6, correct? So 2.6, that is option A is correct, right? So option A is correct here. Clear everyone? So this is the question number 2. Now we are moving to the next question. There is question number 3. Okay, a thin string of negligible mass. A thin string of negligible mass, one end fixed to the roof and is wounded over a circular disc of radius 3 meter and the mass 5 kg. Okay, so the thing is that there is a string. There is a string which is connected on the roof and is wounded on a disc. So this is the disc. Okay, this is the disc on which the string is wounded. Okay, now the disc rolls vertically downward under the action of its own weight. Now, because of its own weight, this will roll down. And whatever the wrapping is done on the disc, that will be opened up, unwrapped. So considering acceleration due to gravity, that is 10. Here it is given 10. Okay, don't forget it. The tension in the string is. So we have to find out the tension in the string. How we can find out the tension in the string here? So what we will do, we will make the free body diagram of this. So here the tension is happening. Here the weight is happening. Okay, that is m into g. Obviously the box is moving like this also, and the box, disc is rotating also. What we can do here? What we can do here? Any idea? Okay, so what we can do here? First thing is that we can apply about this. Consider it as an instantaneous center and about this particular point A. So if I apply the dynamic equilibrium about A, so IA, that is moment of inertia about A into alpha, is equal to net moment. So about this weight is creating net moment, that is mg into whatever the radius is there. Radius is given as a 0.3 meter, right? Radius is given as a 3 meter. Radius is given as a 3 meter. Clear? So this is what we are given with. So what is alpha? Alpha is nothing but m into g into r. I is nothing but, if you remember, for a disc about the g, the I is given as mr square by 2. So about point A, IA is given as 3mr square by 2. Okay, so this is given to us. Now this is 3mr square by 2. Okay, so m and m get cancelled. This is cancelled. So g2 by 3m. This is my alpha right now. This is my alpha right now. Okay, I hope you are getting my point. This is m and m get cancelled. This is 3g by r. This is my alpha. Okay, so now if you apply for the equilibrium in a translation, then mass into acceleration is equal to net force, that is mg minus t. And from here we can find out our t. Okay, so what is t? T is nothing but m into g minus a, and a is nothing but a is equal to alpha into r. Okay, so a is alpha into r, so alpha is nothing but This, so alpha into r is 2g by 3. Okay, so that will give you mg by 3. So actually the tension is nothing but 1/3 of the weight. How much weight is there? How much weight is there? 5 kg. So 5 into 10 divided by 3. How much will be the answer? 50 by 3. 50 by 3. Okay, so what is 50 by 3? 50 by 3. How much it is? 16.66. So I think it is in the option 16.6. B is the correct option. Got it, guys? Till now, is there any doubt in this solution? The solution is clear or not? Please tell me, let me know on the chat box. Okay. So guys, you have to reply on chat also. Okay. Whatever the answers we are writing. So this is the way of solving this question. Okay. So easy question it is, no problem. Now, the question number 4 is in your screen. Let us see now. A bullet of weight 2 grams enters a wooden partition block at a velocity of 1000 meter per second and 0.003 second after entering the block. The average impulsive force acting on the bullet. Okay, average impulsive force acting on the bullet. So what is happening? After entering the block, the bullet moves 0.00 second. Okay, the bullet is in the motion for 0.00 second. Very small time period. Okay, so we have to find out how much average impulse force has been applied to it. So we know that one equation, impulse momentum equation. What is impulse momentum equation? Whatever the average force is there into t, that is time, is equal to change in momentum, that is mass into v2 minus v1. Correct or not? Or v1 minus v2. We can say v1 minus v2. Nothing, anything we can call it. Okay. So the F into T, the F average we have to find out. T is given to us, mass is given to us, that is 2 grams. So 2 by 1000, that will be in kg we can write. Okay, V1 and V2. So entering the particle with the velocity of this much. So initial velocity is 1000. And after 0.003 second, the velocity becomes 0 for the bullet. So the velocity will be 0. What we are doing, we are finding out the change in momentum of bullet. And whatever the change in momentum of the bullet has been done by block, that will be called as average force, okay, divided by its time. So now the time is 0.003, sorry, 0.003 seconds. Okay. So here, what will be the answer? So 1000 gets cancelled out. So we'll be getting 2 by 0.003. So average force is how much? Come on, everyone, let me know. What is the average force? So 2 divided by 0.003, that is 666.66. Okay, this is the answer. So is it clear? The solution is clear, guys. Please let me know on the chat. The solution is clear or not? Is it clear? Okay, so this is done now. Let us move to the next question. So this is the next question. A body of mass m is suspended by 2 strings, making angle 30 degree and 45 degree with horizontal. The maximum allowable tension is 1000 Newton. Okay, the maximum mass of the block is, okay, it's block. It's a block, okay. Oh, so block is, we have to find out the maximum possible value of m is what? If we have given T max is equal to 1000. So any of the string, it's not necessary both the strings are bearing the same tension. And suppose it is bearing T1 and it is bearing T2. So if T1 is less than T2, okay, if T1 is less than T2, then we will consider T1 as a maximum T. Okay, then T max will be equal to T1. And if T2 is less than T1, then our T max can be considered as a T2. That we have to check which one is more and which one is less. Obviously, we can apply the Lami's theorem. Okay, we can apply the Lami's theorem as 3 forces are acting at a point. So this will be your mg, this will be your T1, and this will be your T2. Okay, all are in the tension. Now this is the angle which is given as 30 degrees. So it will become 120 degree total angle. This total angle will become 135 degree. And this will become as what? So 360 minus this and this, how much it will become? Okay, so 180 minus 30 is 150. 150 minus 45 is 105. Correct? So this is what we are having now. Now let us check what is the thing we can get. So applying Lami's theorem. So whatever the force is there and the sine of the opposite angle. So 120 degree. T2 divided by sine 135 degree divided by mg divided by sine 105 degree. Okay, that is what we are having. Now, we want to find out maximum possible of this. Now, first we have to check if V1 is our T, which one is our T maximum. So if we check this from this two, what we are going to get? We are going to get this as a 135 degree. Okay, or what we can do, we can take the ratios also like this. T1 by T2 is equal to sine 120 degree divided by sine 135 degree. I think 120 and 135, I think this is small and this is bigger. This will be less than 1. It means that T1 is smaller than T2. So our T1 is nothing but 1000 Newton we will consider. Okay, sorry. I think यहाँ पे उल्टा हो गया. Right. Whatever the, if T2 is greater than T1, then maximum will be T2. And if this is T1 is greater than T2, then maximum will be T1. Yeah, that will be correct. Then only other tension is less than 1000, right? It should be less than 1000. Okay. So T1 here it will be T2. T2 will be 1000. So now we can find out the maximum possible mass of that. Okay. So it is nothing but sine 105 divided by sine 135. Okay, this is the ratio we are having into 1000. So what we can do, m is equal to how much? G is given. G we can take 9.8 if not given. Okay, so let us take it as it is. Now what we are going to get, let us solve it. Okay, so sine 105 of sine divided by 135 of sine, okay, into 1000 divided by 9.81. Okay, so 139.24. Is it correct? No, I think I've done some correction is required. Yeah. T1 is greater than T2. Is it? Let me check. Sine 20 and sine, oh, right. Sine, so 120 sine is this divided by 135 of sine, that is 1 point. Yeah. So here it is greater, right? Here it is greater. T1 is greater than T2. So if T1 is greater than T2, so it will be T1. So here instead of 135, it will become 120. Now, which is the correct answer? Let me know. Here 9.81 we can divide, so we'll get only m. So which one is correct now? Let me know. So 105 sine divided by 120 sine, okay, into 1000 divided by 9.8. Okay, so 139. Again, it is coming 139. 113 it is coming. Let me check. 55 sine divided by 120 of sine. 1.5. Yeah, correct. 9.81. Yeah, 113.69. 113.69. That is D is the correct answer. We have in the option, right. So here it was greater than T2. T1 was greater than T2. That we have to find out from here. Okay, that we have to find out from here. Okay, so it should be greater than, yeah, this value should be greater than 1. Got it? So this is done. The question number 5. Now let us move to the next question. That is question number 6. This is a very good question of free body diagram. Okay, so be ready. Which of the following is the correct free body diagram of the system shown below? Okay, so come on everyone. Try here what you can do here. Yeah. So Gautam, we have done the previous one. Any doubt here? Can we move ahead? So let me know. Which of the following is the correct free body diagram of the system shown below? Okay, so this is the system shown to us. Okay, so if I try to make it a free body diagram, So we can observe that there is a sharp point and the curve. You know? So the rules of writing a reaction is that if suppose both the faces, both the surface are flat, so then the reaction is nothing but perpendicular to that surface. Okay, that's it. Now, so here one reaction will be there. Now at this point there is a sharp edge and there is a curve. So at this point what happens? We cannot draw the tangent and it's a normal will give you the reaction at that point. No. When two curves are in contact, then it's a common normal will give you the direction of the reaction. Okay, but here the sharp edge and the curve is there. But if we see the whole system is having only three forces acting on it. One the reaction from this, one this mass, and the other is from here. Now direction of this will not be like this or will not be like this. Okay, as object is in equilibrium, we know three force member system, three force member theorem. What is three force member theorem? So if there is an object, if one force is acting like this, if another force is acting like this, then whatever the point of intersection is there, if suppose third force is acting somewhere here, then this and this point will be joined and this will be only the direction of that force. Then only the system will be in equilibrium. So all the three forces on the body should be coinciding at one point. That should be concurrent at time, we can say. So here in this object, this is the point and this is, if you see, this normal force will pass through this CG, right? G. Now this G and this point of contact should be joined, and whatever this direction is there, and this direction the reaction force will be acting. So which one is correct? If you see in the option, not this one, because this is going directly like this, but this one, because this if you match with the G, actually this hashed line was also there in the diagram. It is not written here. So here this will be R2 and B will be your correct option. Got it? So three force member theorem, not A. You are saying A, not A, because see here actually the diagram is not appropriate. The diagram is something like this. This corner is there and there is a surface like this. So what we think generally, whenever there is a curved surface, whatever the tangent is there, it's a normal will give you the direction of the reaction. But here it is not like that because it is a sharp corner. When there are two surfaces in the contact, then common normal is the direction of the reaction. But here one is the sharp edge and the other is the curve. So at this point, we do not know what is the reaction, what is the direction of the reaction. Got it, Kumar? So correct answer is B. Is it clear, Kumar? You are saying A is the answer. So A is not the correct answer. Please check it. I hope you are getting my point. Okay. So I'm moving ahead to the next question. This is the next question, question number 7. Three wires support the work weighing 500 kg as shown in the figure. The tension in the wire BC is. Now what happens here? We see that there are three strings, ED, AD and BC. And we know that if there is an object something like this, so finding out this three reaction at this, obviously we can do that by applying the three equations of equilibrium, that is summation of f of x is equal to 0, summation of f of y is equal to 0, summation of m is equal to 0 about any point. But the thing is that here we have to just find out the tension in the BC. So what we will do, we will try to do that methodology which will take less time. So what we will do, we'll first draw the free body diagram of this. So here one force is acting here, one force is acting here, okay, at this D point, another force is acting here. So this is D point. Okay, so this is TED, this is TAD, this is TBC. Okay, and now one weight is also, don't forget weight. Okay, weight is also acting, that is M into G. Now we have to find out this. Okay, TBC. What we can do, we know that both the unknowns are passing through D. So it's better to take the summation of movement above D and keeping it equal to 0. Why? Because both the two unknowns will not be then involved in this equation and we can directly find out TBC. So what is this? TBC. Okay, so TBC sine theta into whatever the length is 10 meter. Okay, so length is 10 meter minus mg into 5 because this is at the mid part. Okay, 5 meter is equal to 0. Why minus? Because this mg is creating clockwise movement. Clockwise movement is considered as a negative, and anti-clockwise movement is considered as a positive. है ना? So here this I have written this sign convention. Okay. Now find it out. So TBC is how much? That is nothing but mg by 2 into sine theta. Now sine theta is nothing but m is how much? 500. 500 into g how much? G is given 9.8. So g is 9.8 divided by 2 into sine theta. Sine theta. So theta is here how much? 45 degree. So sine theta is how much? Sine theta is 1 by root 2. And this will be your final answer. So TBC, how much it is? Come on, let me know. Okay, so it can be written as root 2. So 5 into 9.8. So 5 into 9.8 divided by 2 of square root. Okay. So square root is where? Yeah, here it is. So there is 3464.8. 3464. 3464, that is somewhere here. Right? This is the correct option. B is the correct option. Okay. Is it clear, everyone? So the answer is B, that is 3664. 3464 is the answer, guys. 1 second. 4.82, right? Something like this. 3464.82, something like this. So I think A is the correct answer, not this B. Okay, so this is the correct answer. Okay, the answer may differ if you are taking 9.8 or if you are taking 9.81. So there is a slight change. Okay, there is a slight change over here. Nothing is about to worry. If you are taking 10, you might be getting something else here. Okay, if you are taking G is equal to 10, you might be getting some other option. That is why you have to take care of G, what is given in the question. And now don't do this silly mistake. So I hope it is clear now. Okay, so let us see one last question. Question number 8. A balloon is going up with the uniform velocity of 10 meter per second. So there is a balloon. Okay, there is a something like this balloon. Okay, there is a balloon like this, and it is going up with the velocity of 10 meter per second. Okay, now a stone is dropped from a balloon when at a height of 4 meter. So when the balloon is at the height of 4 meter, a ball is dropped. When the balloon is at the height of 4 meter, a stone is thrown from here. So when the system is in the velocity v1, so the stone which is thrown from here will also be having the same velocity v, right? And so the thing is that stone will not directly fall down. Okay, the stone will first go upward for some time and then go downward, and then come here like this. Okay, this is the condition. Now we have to find out the velocity of the stone just before hitting the ground. So we have to find out the velocity at this point, that is 2, just before hitting the ground. So if we see from this point to here, the velocity will be 0, and at this point again the velocity will be 10 meter per second. Now if you see, the stone is thrown upward, velocity 0, and then again coming down. So at this level the velocity is same because height is same. So the kinetic energy at this point and at this point is same because height is same. Okay, so the here also again it will regain the velocity of 10 meter per second. Now this is the v1 and this is the v2 that we have to find out. Height is given, that is h is equal to 40 meter, that is. So v1 so which equation we can use? v2 square is equal to v1 square plus 2gh. Okay, because as the ball is coming downward, so g is positive, we can take. So v2 is nothing but v1. V1 is 100 plus 2 into how much g is given? G is 10. Okay, remember g is 10 and this is 40, and you have to take square root of this. How much it will be? 100 plus 800, that is 900. So 900 is nothing but 30 meter per second. So this will be 30. So B is the correct option. Got it? B is the correct option. Is it clear, everyone? I hope you got the solutions of all the questions. You know? So this was the practice question of the BARC. I hope you got some help from here. You know? So whatever the solution you are having, we have solved. I hope it is clear to everyone. So please don't forget to like this video, share it with your friends. So where do you get this question? We can also practice. See, these are some questions that we have observed from some previous year bar questions. So we have compared with that and we have created such question. Okay. So it will be tough for you to find this question in the internet, but some previous year question papers of bar that is not easily available. Okay. But actually we have some of our team members have attempted the questions. So some memory based questions we had already in our database. So from there we have created this question, similar kind of question. Got it? So I hope all the questions were helpful to you guys. Okay, so thank you very much guys, and please share this video with your friends and they can also get the help. So thank you very much. See you in the next session. Bye bye.